Hello there, welcome to Excellent Scholars Academy. And today we're going to use Kirchoff current and voltage law to solve this question. All right, so we're asked to determine the value of the EMF E1 in the circuit above. So now, if you look at this circuit very well, we have E1 and we have E2. All right, so these are the two EMFs, the two voltage sources here. And we're asked to find the value of E1 here. Now we have R1 here, we have R2, we have R3, and we have R4. All right. Now, if you watch, this is I1. I1 is the current flowing from here and then entering here. This is a node. All right. This is a node. All right. So this is a node. So I1 is entering here, and you can see I2 and I3 leaving. All right. I2 and I3 leaving. All right. Now, so we are asked to find E1. Now, but before we can find E1, we have to find I3, because if you notice, I3 is not given to us, but I1 and I2 is given to us. So, but we have to find I3. All right. We have to find I3. Now, let me take you back to Kirchoff's current law. Now, if I have a diagram like this, let's assume that this is I1, and then this is I2, and then this is I3. Now, if you watch very closely, you see that I1 is entering here, entering this node, while I2 and I3 are leaving. Now, what does Kirchoff current law state? Kirchoff current law states that the sum of current what entering a node or a junction is equal to the sum of current leaving. All right. So you can see I1 entering and I2 and I3 leaving. All right. So it means that I1 is going to be equal to I2 plus I3. All right. I1 is going to be equal to I2 plus what? I3. All right. So from here, you can see that I1 is entering, all right, and while I2 and I3 are leaving. So it means that what? I1 is equal to what? I2 plus I3. That's applying KCL, which is Kirchoff's current law. All right, applying KCL. We'll notice that I1 is equal to I2 plus I3. So now, we want to look for I3. I3, when you make I3 in solving formula, is going to be what? I1 minus what? I2, which is going to be equal to, now what is I1? That's 0.5 minus, what is I2? I2 is what? 0.2. So I3 is going to be equal to 0.5 minus 0.2 is going to give us 0.3 ampere. All right. So I3 is equal to 0.3 ampere. Now, we've used KCL to find I3, but the main goal we want to achieve in this question is to find E1, which is the EMF here. All right. Now, how do we find that? We're going to apply Kirchoff's voltage law. All right. Now, I have to rub this off. I hope you understand this concept. All right. So now we'll have to use what? Kirchoff's voltage law. And what does Kirchoff voltage law say? Kirchoff voltage law says that the sum of what? Voltage in a closed loop is equal to 0. All right. Kirchoff voltage law says that the sum of voltage or EMF in a closed loop equals 0. All right. Now, we're going to apply KVL to this loop, because this is a loop and then this is another loop. But we want to find E1, so we only need this loop. So this is a loop, and we're going to take our direction like this. So this is loop what? 1. So applying KVL to loop 1, which says that the sum of voltage or EMF in a closed loop, this is a closed loop, is equal to what? 0. All right. So now let's continue. So now this is E1. We're taking our flow, our direction of our current from here. So it's moving from negative to positive. So it's going to be what? Positive E1. All right. Positive E1. Now there's going to be a voltage drop on this 2 ohms resistor. All right. So what's the voltage flowing through this resistor? We will need the current and the resistor. Don't forget that according to Ohm's law, V is equal to what? IR. So it takes the combination of current and resistance to give us what? Voltage. So for us to know the voltage flowing through here, the current flowing through here from here is I1. So it's going to be 2 times I1, all right, which is 0.5. But it's going to be negative. Why? Because there's a voltage drop. All right, because this battery, we assume that this EMF or this battery supplies this, so there'll be a voltage drop. So it's going to be what? Minus what? Now IR, the current flowing through here is what? 0.5. So it's going to be 0.5 times 2 minus, now here also there's a current flowing through here which is I1. All right, And we know that current and resistance combined together gives us voltage. So it's going to be also negative because there'll be a voltage drop here too. So that's going to be what? 0.5 minus 0.5 multiplied by what? 4. Now, coming here, don't forget we're moving like this, clockwise, all right? We're taking our directional flow like this. So coming to this resistor, we already know the current flowing through this resistor, which is what? 0.3 ampere, which is I3. Don't forget, 0.3 ampere. All right. So the current flowing through here, there will also be a voltage drop here, which is going to be negative. It's going to be what? Minus. So the voltage across here is going to be what? The current times the resistance. That's going to be 0.3 times what? 9 ohms. It's going to be equal to 0. All right. Don't forget, sum of voltage in a closed loop equals 0. So this is going to be what? E1. All right. Then this times this gives us what? 0.5 times 2 gives us minus 1, minus 0.5 times 4 gives us 2, minus 0.3 times 9 gives us what? 2.7 equals 0. So this is going to be E1. Minus 1 minus 2 is going to be minus 3, then minus 2.7. That's going to give us minus 5.7 is equal to 0. Take this to the other side. You have E1 to be equal to what? 5.7 volts. Now, I would like you to try getting E2 and give your answer in the comment section. Don't forget to like this video, share this video, and make sure you subscribe to this channel. And also, do well to hit the notification button so when I upload more videos like this, you get notified because I'm going to be uploading more videos like this. So get ready.